In our last video, I left off with the insight that sampling error would, under a large number of conditions, be normally distributed. We'll spend this module talking about the distribution of sampling error, specifically the distribution of sampling error for the mean, and we'll leave with some insights about how this will allow us to make statistical inference from samples to populations. Before we move into this topic, let's pause for a moment and think about why it would be useful if we were able to assert that sampling error was indeed normally distributed. We know a lot about the distribution we call normal. That is, we know a lot about its proportionality, and because of this, we would be able to make very specific statements if, for instance, we knew that we got a sample that was in one of the extreme tails. Notice what that might imply. Suppose we were doing a study looking at the effects of some drug on IQ. We know a lot about the IQ distribution, and we should expect if we simply were to take a sample that the IQ scores in our sample would average out to be about 100. Suppose we took a sample and treated them in some way and got a sample mean of 140. Well, that seems pretty unlikely to happen if the thing we did to our sample had no effect. We would probably be more inclined to say that whatever treatment we applied caused some sort of difference. But we can't simply make these general statements. How unlikely would a sample mean of 140 be if we were taking a sample from that population that had a mean of 100? We need specific statements about the likelihood of that outcome before we're going to be able to reject that first explanation in science, the one that asserts that whatever we measured was just sampling error. So notice, the normality of a sampling distribution of means, the normality of sampling error, would allow us to make these very specific points about the probability of events. Remember, any distribution that's normally distributed we can z-score, and then we know a lot about the proportionality. So, our goal in this module is to see under what conditions we can assert that the distribution of sampling error is actually normal.